Hello YouTube! I thought I'd do a quick video here on possible simple circuits you can build to help you hopefully not to have to take a radio apart to find a squelch line like I had to do with the Belfang UV5R radio. If you remember that one video, I had to get the higher voltage. I pulled the radio apart and I got my 8 volts. I was able to hook it to the blue box and it worked and life was good. Well, this may prevent that. If your voltage coming out of a radio is too low and you need it higher. So what this is going to do, this particular circuit here will take a low and make it a high. Good example of that. The Retevis RT97 repeater I'm modifying. That don't have any plugs at all. I'm trying to run wire off the circuit board. That does a low for the squelch line. That blue box, which is the R1 2020 interface box, I call it the blue box, that needs a high to work. This circuit right here, will do that for me. And it's a transistor, a resistor, and another resistor. The transistor part number is 2N2222, the general purpose. Type it on eBay. You can get a bag of them for $6. This resistor is a 330 ohm, and this resistor is a 1K ohm. So as long as my 0 volts on this input of this resistor does not go higher than a half a volt, this thing will put out 5 volts. And the 5 volts that's right here, you can get that from a wall wart. You can get that maybe from a plug off your radio. Whichever you can do, you have to use your ohm meter. In my case, I might be able to tap it off. There might be a 5-volt regulator in the Retevis, or whatever the case. Even a 5-volt DC wall wart, this will work because it's getting its 5 volts from this particular source up here. So if I put in 0 here and I hit the emulator, 5 volts. As long as this does not go higher than a half a volt, this circuit will put out a high. That's a high. Let's put a half a volt. I did 0.5 there. And I'll hit the simulate button, emulator button, whatever you want to call it, 4.99. So I could take this circuit, theoretically, in this simulator, build this circuit, and I could hook up that Retevis RT97 to that blue box, and I'll get my high out of it. Okay? So that circuit's might be very handy. Again, 3 parts. Well, if you got to get a wall wart for the 5 volt, 4 parts. This circuit does the opposite. Voltage coming in makes it a low. So you could have, for an example, let's say your PTT command, let's say that has to be 0 for it to work. Let's say an interface box needs it to be 0, but your radio puts out 5 volts for your PTT command, but the interface box needs 0. This circuit should help with that. And I will show you. Let's put this power supply at 5 volt. Per my example I just said. There's 5 volt. We're going to hit the emulate button. Still 0 volts. As long as it's 1 volt or higher, this thing will do 0 volts. It's like it will switch to ground. These transistors are acting like switches. That's what they're doing. Okay? So again, same transistor, 150 ohm resistor. Pretty simple. Obviously, this is a voltmeter here, and these are ground connections, meaning there's a wire that connects there. I just, for simplicity and not to clutter up, schematic diagrams will use these symbols for ground, but they're all the same connection for some of you that don't know electronics. Another circuit that's really handy that I've been playing with. I don't know if you remember my video with my ball fang. Took that thing apart, and it's 8 volts. I put 8 volts to the box. It works. Technically, anything above 3.5 and higher is a high. I just like using 5 volts. That's me personally. Well, I can make a voltage divider. 2 resistors. So, in this example, I'm going to use 8 volts. That's what that bell thing did on that squelch line. 8 volts. 3K resistor. 5K resistor to ground. The meter's cooked up in between the resistors. This is ground. So if I run the simulator, their website might be going to be pokey now on me. This thing has to go online when you do it, so I bet you that's what's going to happen. That's the only, part I don't like about this software. It's got to use the internet. I don't understand why, but whatever. So you have to log in, and it's all free. Okay, so it did connect. I'll post a link to this simulator software down below. At any rate, but 8 volts is going in there. 3K resistor, 5K gives me 5 volt. Now, if I change this resistor, just to show you that, I'm going to change it to 2K, which obviously will not be correct with my 8 volt source, but I want to show you that this simulator does work fairly good. And it went 5.7. So 3K. Now you could use the 0.7 is not terrible, but if you want to be more exact, you could use a 3K resistor, or even for that matter 2.5K. So let's go 2.5K. Let's hit that. We hit 2. That's a kind of a common value. Let's hit the simulator on that. 5.3. That's close enough. So there is a way, if you need to cut voltage back, you can use these resistors, and that should work, especially if it's a low voltage, low current situation, which in these radios it is. We're not dealing with a lot of current, which is good news. Obviously, if you're dealing with a lot of current, you're going to need a higher wattage resistor, but this is low current conditions, so like a 1/4 watt resistor would be sufficient for this. So, at any rate, I hope these values will help you. Again, this is a simulator. I have to build the circuit to see how it's going to work in real life. I do have the transistors on order, so once I get the transistors in, remember, resistors are going to have a tolerance of 5% depending on what type of resistor you buy. If it's a carbon resistor, it's going to have a tolerance of 5%. A metal film resistor will be, I believe, a tolerance of 1%. So it depends on how accurate. You can buy more accurate resistors that have lesser tolerances. And so if you buy the cheaper resistors that are the carbon resistors, they're going to be plus or minus 5%. There's so 33 ohm could be plus or minus 5% either way. So that's why the numbers you see here may be a little different when you actually build the circuit, because you got to take in consideration the tolerances of the actual resistor. No resistor is going to measure exactly 3.30 ohms. That's what I'm trying to say in layman's terms. So, at any rate, I hope this video will help you with your modifications if you need to. Hopefully this will help you prevent taking some radios apart to get the squelch line. Like in my case, I needed a higher voltage, so I had to do that. But this circuit may have helped me avoid taking that apart. But at any rate, so I will post the links down below to the free emulator software. It's pretty simple to use. watch a couple videos on it. I've never used this particular brand before, so it took me about 20 minutes to kind of figure out how to do it. There's all kinds of, obviously there's transistors, resistors, there's all kinds of different circuits. You can even pick a scope, and that's kind of cool. You can you can put a scope on there and measure waveforms if you're building a circuit, and you can see the waveforms, and it's pretty neat little software. Not too bad to use, but at any rate, I will put a link down there. If you have any questions or comments, please post them down below, and please subscribe, and thank you, and have a good day.